Welcome to Subaru Ecu Flash Training Part 13. In this video, we're going to be taking a look at doing our open loop mass airflow style tuning. In the previous video, we were looking at our closed loop operation that really pertained to idle and part throttles. This is going to be where we transition into full throttle or higher load, where we're getting into boost. We're going to be going about the calibration techniques a bit differently. It's relatively simple. We're going to be integrating some of the things we've learned in some previous training tutorials, looking at our air fuel, logging that into our Rom Raider logging, and then creating a custom math channel now in Megalog Viewer, so it can tell us the exact difference between our target air fuel and our actual air fuel, and then what to do with that, how to actually go into the mass airflow calibration curve and update things. We're going to go do a live demonstration on a vehicle in this training tutorial so you can see the process from start to finish. We have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with open loop style fuel tuning with a mass airflow style calibration file. In our last video, we looked at the closed loop style tuning technique for idle and part throttle cruise situations. So we know that we were dealing with in the previous video, looking at our injector flow rate, which we could change. It's a global scaler for idle, part throttle, and wide open throttle. We know that the latency made the largest difference in getting our fuel trim sorted out, part throttle. We also have our mass airflow calibration curve, which we generally don't want to have to touch unless we need to do a rescale, or if we're at very high load in the upper last third of the table here, we might need to go and renormalize this so that it's representing the airflow versus voltage, because this can be thrown off here a little bit. But we have confirmed in the last video that essentially the first 2/3 of the table here, so idle and part throttle cruise operation, are nailed down. We know that the proper airflow registration, we were seeing at idle right around 3 to 4 grams per second. We know that as we started to transition from vacuum into boost, we were seeing about that 1.05 grams per rev threshold within our spark timing table. So we know all of that's right. Now we're going to take a look at doing wide open throttle tuning. And that's going to be a little bit different technique that we're going to be exploring here in this video. We're going to be looking at slightly different parameters, because in open loop, we're no longer looking at the primary oxygen sensor and taking a look at any kind of closed loop trim. So we don't have our air fuel correction number 1 and our air fuel learning number 1 playing any role in our fuel delivery. We are an open loop and we have no corrections being made. So it's going to be left up to us to make sure that the air and fuel model are intact and are accurate, so that when we're commanding a certain air fuel in the target air fuel table, that we're reaching that air fuel and that we're not too rich or too lean. Now, before we jump into the video, there is some things I want to go over here within this particular calibration file. So I've set the basis for doing the wide open throttle tuning safely. What we're focused on here when we're doing any wide open throttle tuning is to make sure that we're first starting off our tuning off the wastegate actuator or spring level. In this case, this has an aftermarket turbo. I don't know what the actuator or spring level is going to be at, but I have zeroed out the wastegate duty cycle table, also lowering down my boost target. Let's go and review this real quick. We always want to start off at the lowest boost possible to get a handle on what's going on with our mass airflow load and airflow representation. So looking here in our target boost table, I've set my targets here as we're looking from roughly 3200 and higher, from roughly 2.17 volt in throttle position and higher. We set our boost at 10 psi. So that is not going to be a factor here. We know that the boost target is relatively low. If we take a look at our boost control wastegate, looking at our initial wastegate, this is our base wastegate duty cycle. I've zeroed this out, meaning that the boost control is no longer going to be a factor in boost control, and it's going to run essentially as it would have no boost control off the wastegate actuator level. So we should be finding that we're near or operating at the base wastegate actuator, whatever that's going to be. That might be 10 pounds, it might be 15 pounds. We've essentially eliminated the boost or having higher boost levels than we like to run right off the bat. Let's go ahead and minimize that. A few other things that I've taken care of here that are relevant for this video and making sure that everything's going to be safe. That's going to be in our ignition timing advanced base ignition timing table. We know, because we've established in the last video, from 0.1 to essentially 0.9 grams per rev in airflow load registration, because our mass airflow sensor curve here is left intact for essentially the first 2/3 of the table, we're going to be finding that these values are going to be relevant in terms of tracking the proper load the way that Subaru has designed the ECU to function in. So the spark timing that we're sourcing here is going to be accurate. We know that at 1.05 grams per rev, that lines up to 0 psi, or the equivalent of 0 psi on a boost gauge. That's the equivalent of where we're transitioning from vacuum into boost. So we know that that's intact. Once we get above here, 1.2 grams per rev and higher, I went into the table and I've made all my values at 2 degrees of spark timing. Now, that's drastically lower than the spark timing we should be running. We should be running probably anywhere from 10 to 20 degree range, depending on what the load registration is going to be in terms of the boost pressure. Now, the reason why I've lowered this down, when we get into boost, if we have too much spark timing that can lead to knock or pre-ignition, that can easily and quickly damage the engine. When we're doing our tuning, we need to filter out and whittle away as many variables as possible. So the first thing we want to take a look at in terms of tuning our Subaru is going to be making sure that we have our fuel dialed in. Once our fuel's dialed in, we can turn our attention into calibrating and tuning our spark timing. And then after that's set up, we can move our attention into dealing with the boost control. So we kind of want to move in this order of operations. Fuel first, then spark timing, then boost control. And in this case, by lowering our boost targets all the way down and our wastegate duty cycle all the way down, we'll run off the lowest boost pressure possible. And by lowering the spark timing down, we've reduced the likelihood of a knock or pre-ignition occurring, so we can just focus on fuel tuning. We don't have to worry about these other variables. We need to do one thing at a time, and this allows us to Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.